Hello everyone, welcome all. In this lecture, we are going to study the Bowditch balancing. Now, why this Bowditch balancing is required? Bowditch balancing is required in the your theodolite surveying where there is an closing error, and to minimize or to reduce or to make error-free traverse, we need to adopt or we can adopt this Bowditch balancing method. So in this lecture, we will learn the balancing a traverse, then Bowditch method versus the what you can say Galet's traverse method. There is another method similar to this, and the types for the traverse survey at the last. So Bowditch was the name of scientist, and he has invented this method. Now, step by step, we will see it. Let us assume that your traverse is like this: A, B, C. Now, your starting point and end point should match to each other, but there is an error, and that E is nothing but your closing error. Okay, so while applying the correction to this error, that correction should be equally distributed between this AB, BC and CA. Okay, now that correction is to be applied, the correction is to be applied linearly as well as angularly. Now, what is this linear error and angular error? Suppose that your line AB is there, but that line AB, instead of this point B, this should be here at B dash. This is your correct position for this point B. So by an angle theta, you need to deflect it, as well as by the length or linear correction, you need to relocate it. So this is nothing but what you can say your linear correction or linear error is there. So for this error, you need to apply the linear correction. And this theta is nothing but your angular error. So for this error, you need to apply the angular correction. Okay. So angular error and linear error. These are the two types of error. Now, to balance it, we need to study one thing, that is your linear error your linear error is directly proportional to the square root of length. So we need to understand this thing, as well as your angular error is directly proportional to the inverse of square root of length. So these two things we need to keep remember. We need to remember these two things in our mind. These two errors are proportional to the square root and inverse of square root of the length. Okay. Now there is what you can say another term, and that term is your latitude and departure. Okay. So now what is this latitude and departure? We will see it step by step. Your latitude is a vertical impression, while as your departure is an horizontal impression. Okay, such like that when you see the your globe, you have the latitude as well as longitude. Okay, but here in this case, in the surveying, this thing is quite different. Okay, so now I will illustrate here what is the latitude and what is the departure. Now just see here, what you can say, one line will be here. So this line will be your AB, having an angle with the y-axis as theta. Now you remember here the angle taken here is with respect to your y-axis, not with the x-axis. Okay. So now your this vertical offset and horizontal offset, there will be two offsets. One will be on x-axis, one will be on y-axis, right? So you can locate this point B through the coordinates, right? To the y coordinate and x coordinate. So the y coordinate will be here the latitude, that is L, and this horizontal will be your departure, that is capital D. Okay, so your capital L will be, if small l is the length of the AB, then AB cos of theta, and D, the horizontal will be your AB sine of theta. Now you remember here the horizontal departure is multiple of the length multiplied by the sine of theta, while as the vertical latitude is length multiplied by cos of the angle, because this angle is vertical. So that's why this thing is here. Now after that, to reduce this error, to minimize this error, to apply the correction to that error, your summation to latitude and summation of departure will be equal to 0. If this condition satisfy, then your error will be vanished and the full correction will get applied to your travels. Now, to apply this type of thing, you need to separately find the correction for latitude and correction for departure. Now, what is this correction for latitude and correction for departure? There is one formula, and that formula I will write it here. That formula is summation of latitude multiplied by length divided by summation of L, and now this L, remember this L will be the perimeter of your traverse, means summation of all the lengths of all sides. Okay, and this L will be your length of the particular side, such as the length of AB. Okay, so now after that, for correction for the departure, summation of all the departures departure of all the sides multiplied by length of the your one of the side divided by summation of your whole again your whole perimeter. Okay, so I hope that you have got this formula. Okay, so now recently we have discussed the two formulas. First formulas are for the calculation of latitude and departure, that is L cos theta, L sin theta, means AB cos theta, AB sin theta. After that, we have discussed the formula for CL and CD. Now, CL is your correction to latitude and CD is your correction to departure. Okay, so correction to latitude, summation of all latitudes means all the sides we separately calculate the latitude, then we make the summation of that thing. Now, suppose that you are having one traverse, suppose that you are having certain traverse such as the your A, B, C, and D. If such traverse is there, then what you will do? You will separately find the you will separately find the latitude and departure for the east sides for this ABCD traverse. Okay, you make the summation of all the latitudes here, as you can see here, and after that you apply this formula summation of latitude multiplied by length of each side divided by summation of all the perimeter. Perimeter means AB plus BC plus CD plus DA, addition of all the sides. Now you will ask that how what is the methodology to write it? Now the methodology is to prepare the table. Now I will explain you that which columns you should include in that table. So that columns I will explain to you so that the confusion in your mind will not be there. Okay, because once the table is clear, the concept of table is clear, then it will be very much okay for you to understand the various new terms. Okay, so there are no that much new terms. Only the term is latitude departure, correction to latitude, correction to departure. Okay, so I will just now what you can say discuss the table. Okay, so in our table, firstly, what you will have the what you can say uh, sides sides of your traverse. Suppose that AB is there, then BC is there. Okay, these are the sides. Okay, now after that, what you will have the length of that sides. Okay, you will have the length. Length should be given. Suppose that the length will be 100 meter, then 200 meter. Okay, this length will be given. After that, the bearing will be given. Now, if suppose that whole circle bearing is given, then you need to convert it to the radius bearing. Okay, so how to convert the whole circle bearing into radius bearing? Suppose that this angle is your 120 degree. Okay, now how you will convert this 120 degree? You can convert it as this is your east, west, north, and south. Okay, so 120 180 minus 120 will be your 30 degree, will be your 60 degree. This will be your 60 degree, right? 60 plus 120, 180. So this is now your 180. After that, how will be your radius bearing? This is in clockwise direction. Now your whole circle bearing for this is 120, right? In clockwise direction measured from the north. The radius bearing for the same thing will be south 60 degree east. You are going from south towards the east, right? This is your east. So south 60 degree east. Remember always that your radius bearing will always be either from north or from south, either in east direction or in west direction. So this is in short about the your whole circle bearing as well as the radius bearing. Okay. Now let's moving toward or coming back toward the our table. So our table will have the length as well as after that radius bearing, then whole circle bearing. After that, what you will have the what you can say your latitude and departure. Okay, so you might have calculated the latitude and departure. That thing will be here. Okay, now after that, at the end, what you will do? You will do this summation of latitude and summation of departure. Okay. Now after that, these two things you will have the correction to latitude and correction to departure. So this thing you will have. Okay. So that correction you will get from this formula CD and CL, just we have discussed. Okay. The formula for CL I will again write it. Summation of L multiplied by length divided by perimeter. Formula for correction to departure. Summation of departure length of side multiplied divided by the total perimeter. Okay. This was the simple formula. Now after that, after calculating the latitude and departure for the all of the your sides, your traverse will not have only two sides. Here I have written, though I have written the two sides AB and BC, but you may have the three side, four side, five side, six side. Okay, for triangle, rectangle, pentagon, hexagon, likewise that. Okay. Now after the calculating your latitude, CL and CD, you need to apply the correction. So after applying the correction, what you will get? You will get the your what you can say corrected the corrected value of latitude and corrected value of departure you will get. Now how you will get the corrected values? You have to make the addition of these two. You have to make the addition of these two to get this value. Okay. Again, you have to make the addition of these two to get this value. Okay. Now, if your summation of latitude is positive, then your this value you need to put a negative. If this value is negative, then you need to put this value positive. Now, same for the departure. If your summation of departure is negative, then your value here CD will be positive. If your summation of departure is positive, then here this value in this CD column will be negative. So if this is vice versa, means inverse like that. If summation of L is positive, then correction applied should be negative. If summation of L is negative, then this correction applied to be positive. Okay, so it is like that. Okay, so after addition of these two, you will get the corrected values, and the summation of L here and summation of D here, this should come to be 0. Then only your numerical is right, means your steps are right. This summation and this departure summation should be 0. Okay, I am writing here 0 so that you will remember, because you have applied the correction in such manner. If this is positive, this is negative. If this is negative, this is positive. If this is negative, this is positive. Okay, so the correction is applied in such manner simply. Now after getting the corrected value of your latitude and departure, you will get the corrected value of length here. Now the formula, next formula for the length. What will be the formula for corrected length? Which length? The length of the sides, such as the AB. The formula will be under root of L square plus D square. Simple formula. Which L and which D? This corrected L or corrected D and corrected D. So by applying this formula, what you will get the corrected value of lengths of all the sides, and after that you will plot the traverse, whatever the traverse you were having, such as the your A, B, C. This traverse you will plot, and your starting point will match with the ending point. Okay, so in this way, the error is eliminated and 100% correction is applied by using the Bowditch method. Okay, so this is all about this Bowditch method. Now the next thing is the traverse rule or traverse type of method, transit type of traverse method. But before saying that thing, one thing I am going to tell you that this method is easy, and in exam you can solve this what you can say numericals based on this method. If someone asks you in exam about your examiner might ask you about the latitude and departure, apply the correction for the traverse, then you can solve that same numerical by using the Bowditch method as well as Gale's traverse table. Okay, so Gale's traverse table is also similar to this, but the only difference is that the table is quite different. Okay, similar table is there, but some columns are different. Only this thing is there in Gale's traverse table method. But I will recommend all of you to solve these numericals by using the what you can say Bowditch method. Okay, now one more thing for the traverse, that this is what you can say a note, you can write it down. Whenever remember one thing, whenever you are having these lectures, you should be with your calculator, calci, then your notebook, pen, pencil. So all these things you must have with you, and you study it as if you are sitting in your class. You are having just a live lecture in your class, and you are taking the notes. So in this fashion, in this manner, you have to study it. Now, one more thing for the students, to check the interior angles, to check the interior angles of the traverse, what you need to remember, that summation of all angles is equal to, all angles means all internal angles, having this formula you can apply 2n minus 4 into 90. So if you are having such traverse such like that, A, B, C, D, and yes, A, B, C, D. So if you make the summation of all these internal angles, then your summation must be equal to this. Okay. The next formula for summation of what you can say exterior angles is equal to 2n plus 4 into 90 degree. So the same formula, only the sign is changed. 2n plus 4 into 90 degree. This is for cross checking the your traverse. Okay, so after all the calculation, you can check your traverse whether it is satisfying this condition or not. Now the next thing about the accuracy in the traverse. Okay, so that accuracy I will tell you in short, that how this accuracy is having what you can say, how that accuracy you can achieve by using the different methods while traversing. Such like that the conventional methods are there for the traversing. Now, which are the conventional methods? Such like that the chain traversing is there. Okay, chain traversing is what you can say one conventional method. The another method is compass traversing. So first came the chain traversing. After chain traversing, you are having the compass traversing. After that, on third number, you are having the a fast needle method, of traversing. After that, and fourth number, you are having the what you can say observation of angles between the lines. So that is nothing but internal angles. Okay. So these are the four generalized methods. In chain traversing, the error may occur. So it is a less accurate method. After that, compass traversing, you have the some precision. Now after that, the fast needle method. In fast needle method, in compass method, what you do, you I will just draw here one traverse, a simple traverse to make you understand. Now this is a simple traverse. In compass traversing, what you do, you just change the your station points. You keep the compass at different station point and relocate it. Okay, and you take the your MB, that is the magnetic bearing at each station point. But in fast needle method, what happens that you just fix here one magnetic bearing, and with reference to this bearing, you take the reading at different stations. So this fast needle method is more accurate than the compass traversing, because here one bearing is fixed, and with reference to this angle, you take the various other angles. Okay, means this magnetic bearing is your fixed; it will not change. Okay, so there will be no question of the your errors here. After that, one more accurate method, more accuracy you will have than this in the internal angles method. Here you calculate the various internal angles. Here you will have the internal angles. Means internal angle means what? That what you can say, you are going to have this angle. After that, this angle, and this angle. So addition of this angle, all internal angle, you can check it with 2n minus 4 into 90 degree. So that's why this method will be more useful, highly useful. Useful means highly accurate. So this is the level of accuracy from upward to downward here. Okay. So I hope that you have understood this type of thing. Now in our next lecture, what we are going to see is the tachometric survey. Okay. So I hope that you have understood this theodolite survey. This is the your last topic in theodolite survey, that is the Bowditch method. Okay. So what is the name of the method that we have seen today is method Bowditch method of the applying the corrections to the errors in traverse. So this is all about your Bowditch method. So thank you all for patiently listening the lecture.